Hello guys, this is Sushant. So welcome to your channel, which is Sci Engineers. We have been making videos for the first year engineering students, and we have also started uploading for the preparation for the engineering entrances. These set of videos are going to be the generalized version of various engineering entrances like the MHTCET and JEE preparation. It will also help you in your preparation for the board exams. So please do hit the like button, please do subscribe to our channel, and do share it with your friends if you like these videos. Do write in the comment section how do you find these videos, whether it is helping you in your studies. And also let your friends know about the various videos which we have uploaded and which will be uploaded soon in this particular channel. So never forget to like our videos and never forget the channel name, which is Sci Engineers. So let's get going. So we are going to see some of the complicated versions of derivatives and how to solve them in a quick manner. So let us see the first sum which is based on it. So let us take this particular problem which is given to me, where y is equal to root of 1 plus e raised to x upon 1 minus e raised to x. So in this case, if you take the derivative of this term directly, you can see that you have a root term which is present, then you have the u by v which is present, and you have the e raised to x which is present in it. So it's going to be quite difficult to solve this problem directly. So whenever you are having an exponential term, terms which are present in product form, or terms which are going to be present in division format, in that case the simple solution for it is to take log on both sides. So if you take log on both sides, you are going to get a log y is equal to, you can see that this is nothing but the whole term raised to half. So when you're taking the log of it, the half part gets in the product format. So it's going to be product of the log of 1 plus e raised to x. Now since you can see that inside the root there is a division which is present, so for that division it's going to be a log of the numerator minus log of the denominator part. So it is just nothing but the application of the properties of log while solving this. Now when you are taking the derivative, so differentiating with respect to x, when you are taking the derivative part of it, you have to be quite careful over here. You are having the log y term over here. So you know that log of anything is going to be 1 upon that thing. So it's going to be 1 upon y. But since my y is not x, we have to take derivative of it. So that's going to be dy by dx. This thing is equal to 1 by 2 into, you can see it's log of 1 plus e raised to x. So it's log of the term, which is 1 upon that term, into the derivative of the term which is present in it. You can see that inside it is 1, which is a constant term, so that's 0. And e raised to x, which is having the derivative as e raised to x. Then it's going to be minus of this particular thing. So you can see that it is again a log of that thing. So it is 1 minus e raised to x into the derivative of minus e raised to x, that's minus e raised to x. So you will be having your dy by dx is equal to, you can have the half outside, and you can even take the e raised to x term outside. So you will be having this as e raised to x into this thing, and you can see that the y comes over here, so you can write the y in this format. This thing will be multiplied by 1 upon 1 plus e raised to x minus, and this becomes plus 1 minus e raised to x. Now when you are taking the LCM, it's just going to be the cross multiplication of it. So it's going to be this bracket into this bracket, and this whole thing is going to be in this format. So it's going to be 1 minus e raised to x plus 1 plus e raised to x. So the e raised to x part gets cancelled. You have a 1 plus 1, which becomes 2, which can be cancelled over there. So you will be getting your dy by dx term as this, e raised to x y divided by 1 minus e raised to x into 1 plus e raised to x. So you can just substitute your y in this thing. So you will be having e raised to x divided by 1 minus e raised to x into 1 plus e raised to x into your y term. So your y term is nothing but this. So that's 1 minus e raised to x divided by 1 plus e raised to x, the whole raised to half. Now in this case you can see that 1 minus e raised to x half and 1 minus e raised to x, the half part gets cancelled from there. So it's going to be e raised to x into root of 1 minus e raised to x, this part, and this is 1 plus e raised to x into the half of that. So that's going to be 1 plus e raised to x raised to 3 by 2. So this is your derivative, that is dy by dx, when you're taking log of it. So let us see one more type of sum like this. So let's see this particular sum which is given to me, which is y is equal to log of sec x by 2 plus tan x by 2. Now you can see that there is already a log term which is present, and you have addition which is present inside the log. So the log is not going to help us in solving this in a quick way. So what you can do is, instead of taking a log as it is and taking the derivative part of it, what you can do is you can take the anti-log, or you can take the exponential term. Now whenever it is not mentioned with what base it is, you have to assume it is to the base e. So when you're taking the anti-log of it, it's going to be nothing but the exponential e raised to y is equal to sec x by 2 plus tan x by 2. So when you're taking the derivative of it, you know that derivative of e raised to anything is going to be the same thing. So differentiating with respect to x, you'll be getting this as e raised to y into, you don't have a x term over there, so that's going to be the derivative of that term, that is dy by dx, will be equal to your derivative of sec, which is nothing but sec x tan x. So it's going to be sec x by 2 into tan x by 2, and you don't have a x over here, you have x by 2, so derivative of that is half, plus derivative of tan x by 2, so that's going to be nothing but your sec square x by 2 into again the derivative of x by 2. So from this you can take the half sec x by 2 common. So you will be having your dy by dx is equal to half into sec x by 2, which is going to be common, into this particular term, which is nothing but your tan x by 2 plus sec x by 2. Now you can take that e raised to y in the denominator part, so it's going to be divided by e raised to y. But you can see that e raised to y is nothing but your sec x by 2 plus tan x by 2. So that is why this gets cancelled. So you are having your dy by dx as half sec x by 2. So you'll be seeing some more sums, some more types of differentiation sums in the upcoming videos. So for them you have to subscribe to our channel. If you're new to the channel, hit the bell icon to never miss a notification from us, and also do like our videos and do comment in the comment section. We are from Samartha Vidya classes, which is for engineering and science level students. We have been helping students for the preparation of the engineering entrances. So if you want to know about us, you can email us at samarthavidya@gmail.com, or you can visit our Facebook page, which is Samartha Vidya. Both the link of the page and also our email address is given in the description below, so you can just go and have a look at it. So this is Sushant signing off. So keep learning, keep watching, and happy learning. Bye.